Hello students, the question that we have here today says a block weighing 10 Newton travels down a smooth curved track AB joined to a rough horizontal surface as shown in the figure. The rough surface has a friction coefficient of 0.2 with the block. If the block starts slipping on the track from a point 1 meter above the horizontal surface, how far will it move on the rough surface? So, if we just understand the situation first, this is the initial position of the block A and it slides down along this smooth surface, and by the time it reaches the position B, it gains a certain velocity, right? As now it moves on this horizontal ground which is now rough, because of friction the block will slow down, and let us say upon reaching its new position C, it stops. It loses all of its kinetic energy by the time it reaches the position C. The final velocity at C will once again be 0, right? So, the standard process for doing such a question is, we first find out the velocity of the block as it reaches the position B by using the law of conservation of energy between the points A and B, because we know that the track between A and B is smooth, right? There is no friction there. So, all the potential energy at the position A will convert into the kinetic energy at the position B. And then knowing the velocity at the point B and knowing the frictional force that acts between the points B and C, finding out the acceleration from that force, we can use the equations of motion to calculate the distance that the block will travel. Let us assume this distance is x, to reach to a position where it once again comes to rest, right? So, we start with using conservation of energy principle between points A and B. We say that all the potential energy at A, which will be mgh, let us say, the value of h by the way is given to us, we will substitute it a little later. Mgh is equal to half mv squared, which gives us v is equal to root of 2gh. Yes, and this becomes the velocity at the position B, which is now the starting velocity for the horizontal portion where the block moves with along with friction. So, now between points B and C, can we first find out the frictional force and hence the deacceleration that the block will suffer? So, friction, which will be kinetic in nature here, we know will have a value of mu n, which we can easily calculate. 0.2 is the value of mu, and n, which is mg, is given to be 10 newtons. So, this comes out to be, okay, maybe instead of putting the value of mg here, we will just keep it as mg and see if we can get the answer in terms of variables itself. So, this is our frictional force, and from here if we try to find out the deacceleration of the block, it will be the force of friction divided by the mass m, which will give us 0.2 mg by m goes away and we will be left with 0.2 g. So, this gives us the acceleration, which we see is a constant, right? And since acceleration is a constant, we can now use the third equation of motion between the points B and C to find out the distance travelled in the process of the velocities changing from one value to the other, right? The third equation of motion says v squared minus u squared is equal to 2as. And when we substitute the values here, we want the final velocity at the position C to be 0. So, 0 minus initial velocity, we have already found this is the initial velocity for the path BC, right? So, this is root 2 gh squared, so it will be 2 gh is equal to 2 times acceleration here, understand, will be negative. This is a deacceleration, so we will put it with the minus sign, 0.2 g with a minus sign into x, the displacement that we have assumed for the block between the points B and C. So, when we calculate this value of x from this equation, see that 2 and g will cancel out and we will be getting x is equal to h by 0.2. It's basically it is h by mu. If you look at it, this 0.2 is the value of mu. So, we can just substitute the values of h, it is 1 by 0.2, which comes out to be 5 meters, which is our answer. See that we have done this question here in 3 steps. First is we have found the velocity at the point B, Then we have calculated the deceleration of the block between points B and C, and then we have used the equation of motion between the points B and C. Yes. There is a shortcut method for this question where we just by using one single equation we can get our answer, final answer, without having to do all these calculations. What we can do here is we can use the work energy theorem between the points A and C directly, where we can find out the work done by all forces between the points A and C and then put it equal to the change in kinetic energy. If we look at the figure, we understand that between the points A and C, which we can divide of course into two parts, from A to B and then from B to C. Between the points A and B, there is no friction, right? There is only gravity and normal reaction acting on the block at any point in time, wherein the normal reaction will always be perpendicular to the direction of motion of the block. So when we talk about the work done by normal reaction, it will always be 0. Whereas mg will be the force that will do work as the block falls down from the point A to B. Not falls down, it moves down from A to B. So between A and B, it is only the force of gravity which is doing work. Whereas between the points B and C, gravity, which is now perpendicular to the direction of motion, will not do any work. It is only friction now which will do work between the points B and C, right? So we have an alternate method for doing this question. Another way, which is by using the work energy theorem. And here we say that we are using it between the points A and C directly, where we say that the work done by all forces is equal to change in kinetic energy of the block. Between the points A and C, we can say that the work done is by gravity between the points A and B, plus the work is also done by friction between the points B and C, and this should be equal to the change in kinetic energy between the points A and C. Now, if you look at the figure carefully, point A is the point where the block starts off from, so the velocity there is 0. At the point C, once again the block comes at rest. So, kinetic energy, velocity, and hence the kinetic energy is 0 there also. So, the change in kinetic energy here will be 0. The initial and final, both kinetic energies are 0. So, the change is 0. And now we substitute the values for work done by gravity. Work done by gravity between A and B, do we understand from the figure that it will be nothing but mg into h, where h is the vertical displacement covered by the block in the process of moving from A to B. Work done by gravity will be simply mgh, plus work done by friction will be the frictional force, which in this case will be mu mg, times the displacement of the block, which we have considered to be x, with a minus sign because the displacement is opposite to the force of friction. So, the friction will do negative work here. This is the work done by friction, and this term should go to 0. And from here we understand that we can directly get our x value as x is equal to h by mu, which is once again 1 by 0.25 meters. So, see that here we have just used one single equation to get our answer, and that simplifies our question, our working of the question a lot. Thank you.